66 billion. Ton 618 is not a black hole. Not in any sense your mind has ever imagined one. Forget the word. Forget the image. That orange ring you've seen 100 times. That's not what this is. This is a place where space itself has been folded so violently that the distance from one side of it to the other would take you, driving at motorway speed, without stopping, 445 million years to cross. Our entire Milky Way galaxy would fit inside it, twice, and we have absolutely no idea how it exists. In 1957, astronomers noted an unusual faint object near the border of Canes Venatici. In 1970, radio observations at Bologna confirmed it. A quasar blazing with the luminosity of 140 trillion suns, 10.8 billion light-years away. Not a galaxy, a single point. TON 618. By the end of this video, you will understand why some physicists believe this object should not exist at all. For most of the 20th century, black holes were theoretical. Einstein's general relativity, published in 1915, laid the mathematical foundation, and within months, Carl Schwarzschild's solution implied that space could curve so severely that nothing, not even light, could escape. Scientists spent decades assuming something would prevent such objects from ever truly forming. We believed the largest topped out at perhaps 1 billion solar masses. Stellar black holes, born from dying stars, were 10 to 20 times the mass of our Sun. The supermassive ones at galaxy centers may be 1 billion. Our own Milky Way has one at its center. Sagittarius, a star, measured at 4.3 million solar masses, an entire solar system's worth of space folded into a volume you could cross in a few light hours. Astronomers spent 30 years tracking stars swinging around it at millions of kilometers per hour just to confirm it was there. You have probably seen the photograph, the orange ring from the Event Horizon telescope. That is a black hole 6.5 billion solar masses, terrifying, enormous. The small end of the scale. We thought we understood the ceiling. We were off by a factor of 66. Ton 618 does not have 4 million solar masses, it has 66 billion. That number has been measured, checked, measured again with a different instrument by a different team using a different method. The lower of the two results is 40.7 billion. The higher is 66 billion. There is no version of this where the answer is small. Every model we had predicted that a feeding black hole would eventually generate so much radiation pressure it would blow its own food supply away, starve itself. The theoretical maximum, around 50 billion solar masses. Ton 618 looked at that ceiling and kept going. In the early universe, there were lots of quasars or active galactic nuclei, and some were expected to be powered by black holes as big as 10 billion solar masses or more. These new supermassive black holes may be the missing link between quasars and the supermassive black holes we see today. Professor Chung-Pei Ma, UC Berkeley, Department of Astronomy, 2011. We built the family tree without knowing the largest member existed, and that was not the strangest part. The strangest part is that it should not have had enough time. Ton 618's event horizon has a Schwarzschild radius of approximately 1,300 astronomical units, roughly 194 billion kilometers. Full diameter, about 390 billion kilometers. At motorway speed, 445 million years to cross. Neptune's entire orbit around the Sun is 30 astronomical units across. Ton 618's event horizon radius is more than 40 times that. You could stack the outer solar system inside it 40 times over and still have room. Black holes grow by feeding, matter spirals in, heats to millions of degrees, accretes, but radiation from infalling matter eventually pushes new matter away. Above that limit, the Eddington limit, feeding stops. For TON 618 to reach its current mass, it would have had to feed at or near that limit every day without interruption from the universe's first billion years, starting from a stellar black hole, eating at maximum speed. You still barely get there. The math only works if TON 618 started enormous, or if the early universe contained conditions we have never observed. We are not seeing TON 618 as it is. We are seeing it as it was 10.8 billion years ago, before our sun existed. The light hitting our telescopes tonight left TON 618 when the universe was less than a third of its current age. What we are observing is a fossil, a frozen image of the universe's violent adolescence when objects like this gorged on gas clouds that no longer exist in those quantities. And we have no confirmed mechanism for how it got so large, so fast. It is like finding a fossilized skeleton twice the size of anything evolution can explain, and realizing the animal was still alive when your grandfather was born. Not every astronomer is alarmed. Some argue TON 618 is an extreme outlier, statistically inevitable given a universe this vast and this old. The models may simply need refinement at the extreme end. But an object that breaks your model is not a footnote. It is a question the model has not answered yet. In 2011, astrophysicist Chang-Pei Ma at UC Berkeley co-led the team that measured what were then the two largest black holes ever directly confirmed, each roughly 10 billion solar masses in giant elliptical galaxies over 300 million light-years away. The results exceeded every existing model. Ma had spent years building simulations of how the largest galaxies formed. The observations broke her models. That is a specific feeling. The moment a scientist's framework, years of equations, predictions, peer-reviewed certainty, collides with a number that should not exist, not triumph, something closer to vertigo. Because the feeling TON 618 produces is not the clean awe of a beautiful equation. It is the specific discomfort of realizing that the universe is not scaled to us, not even slightly. We imagine the cosmos through human analogies, cities, football fields, years, and those analogies simply do not reach. 66 billion solar masses. The combined mass of every star in the Milky Way, all 100 to 400 billion of them, totals an estimated 64 billion solar masses. TON 618's black hole outweighs the entire stellar content of our galaxy. Every star, every one. The James Webb Space Telescope is now probing the universe's first few 100 million years, exactly when objects like TON 618 were forming. Early results have already found black holes larger than our models predicted. The puzzle is getting harder, not easier, which means the questions that matter most are still open. What seeded TON 618, a collapsed star, or a gas cloud that skipped the star stage and fell directly into darkness? Are there larger objects already out there, hidden behind dust, red-shifted past our instruments? And here is the thing about unanswerable questions in cosmology. They tend to get answered. In 1998, two teams independently discovered the universe's expansion was accelerating, a result so unexpected both groups spent months looking for their own error. There was none. Perlmutter, Schmidt, and Rees won the 2011 Nobel Prize in Physics for being right about something that made no sense. TON 618 is that kind of question. TON 618 is not a black hole. Not in the sense the textbook describes, not in the sense the models predicted. It is the densest concentration of mass the observable universe has so far produced. A knot in space-time so severe that our language, our mathematics, and our intuitions all fail at its edge. And it exists 10.8 billion light-years away, indifferent to our attempts to describe it. The universe did not build TON 618 to frighten us. It built it because the conditions were right, and nothing stopped it. No rule intervened, no ceiling held. The most terrifying thing about TON 618 is not its size. It is the reminder that the universe has no obligation to be comprehensible to us.